Hi, welcome to another episode of Better Performance. Here we are going to discuss onto the gRPC next section. In the previous section, we have discussed some part of the communication style. Basically, as you remember this slide where I was discussing onto the design pattern. When we talk about the communication style, it has many different ways. Sync and async between intercommunication and external communication. In both the cases, we can have the multiple choices, like we can have the Kafka, we can have remote procedure invocations, basically RPCs. We can have the HTTP calls, basically a TCP call, like REST or SOAP over XML, JSON, or any direct communication. But we have discussed onto the gRPC, which is the new pickup into the market, and this is giving a better performance than the traditional communication. If you look onto the gRPC methods, there are four different type of service methods, where majorly it is unary method, server streaming, client streaming, and bidirectional streaming. When we talk about the unary method, it is client and server, where client sent a single request in response, server sent a single response. Whereas when we talk about a server streaming, client sends one request and server respond that with series of responses. If you look onto the certain examples, basic examples is that when you send that shopping cart, you are sending that I need some search. On that search, if there are multiple items, server gets that and starts sending that, and once it is completed, it sends that my all the request I have sent. Second example onto the server streaming is that you get the quote, basically stock exchange quote. You have defined that your quote list, you send that it is my quote list, it has went to server checks one by one quote and starts sending as a streams to server, to client. Whereas next is a client streaming, where client sends multiple informations or multiple requests. As soon as the request completes from the client end, server accumulate all those requests and start processing and then send the information back to client. If you look onto the examples, there are many. For example, whenever you have the order, 5-6 different orders you have, it takes that 5-6 different orders from the cart and goes to a server for single processing. That is a client streaming. Whereas we have that bidirectional streaming, which is the last. In the bidirectional streaming, subscriber or a client sends multiple requests and server start consuming that and providing that as a response. So it goes on to the ping pong, where client sends one request or a series of requests and server chooses to send the response immediately or later. Here, order of sequence into the streaming is always defined and it is not changing. What order client has sent, server understand that order and can send. Here, if server chooses to change the order, it can, or if client chooses to change the order, it can. Anytime one can send the request and one can send a response that. So this is a bidirectional streaming. Coming next, that what are the performance perspective onto these? Whenever we use any of the method, we have to be very careful on defining the parameter of RPC call. I will tell you, more majorly I have seen in the real life applications that people create that blocking stubs, and that blocking stub is always costly. So it provides that different channels. Channel is basically a tunnel which has been created between client and server, and client sends that informations over the channel with the different threads. So one channel can have hundreds or thousands of threads, executor pool threads you can define and use that. In this, A basic funda is that it's not you have that one channel, you should have multiple pool of channels to be defined at the client, and you have to use that. Second, if you have a different type of workload, it is a low workload or a high workload, you can define the different channels, and each channel can have its own thread pool. For example, if it is a high workload, you need to define a high thread pool, or if it is a time taking process at a server, then you can define a smaller thread pools, executor thread pools. Whereas if you have a similar and different kind of calls, let's say one is a user call, another is a transaction call, you know that user calls are lesser whereas the transaction calls is higher, then you can define onto the user call lesser number of thread pools, whereas higher number of thread pools onto the transaction calls. Also, you should use non-blocking stub or listenable feature. What is that? If you use that blocking stub, it goes and blocks that next thread to be executed until it completes its response and give it back to server. But in the listenable feature, you give the response, it gave that, okay, it has accepted that informations. Now, in future, you define that whenever you want to pick up that information. So once it completes the request, it sends back as a stream to client for listening that, okay, your request has been completed and here is the response. So this listenable feature always provides a very high throughput, where I have seen that in the past we have discussed that it is 6 times or 7 times better. But if we go onto the listenable feature, it can give you 100 times better performance than the blocking stub or the normal gRPC call. The last two things is that always you should have a keep alive ping. Generally, if gRPC channel is sitting idle, after some time it goes onto the defunct mode or it is not accepting the request. So you should keep the ping before it goes timeout. So you can define the timeout. Let's say timeout is 100 seconds, and your keep alive ping, you define that less than the timeout. So if you define 90 seconds, so every 90 second it goes and ping to the server. If load is there, it's fine. If load is not there, then also it will keep the channel always open. The last thing is that deadline from the client and server. Often it happens that client requires my request to be completed. I'll give you some examples in the real life. Whenever application, it is a mobile app or it could be your any telecom calls or financial calls, you have a time limit that if within this time, if server is not responding, I need to move ahead and start going on processing the second request. So here client always provides that deadline, that what is my deadline. Let's say it says that 2 seconds is a deadline. Server understand and server also keep responding within 2 seconds. If it is more than 2 seconds, it will stop working onto that request. So this will always improve the gRPC performance at a server side and a client side both. So this is all onto the performance perspective of gRPC. If you have any questions or any comment, let me know. I will respond onto that. Also, in the next episode, I am going to discuss onto the reading of AWR, basically automatic workload on Oracle, where we are going to understand that how it will help us in improving the performance of our applications, how we can read and apply some of the basic things which will improve the performance of application. So I would say keep experimenting and better performing. See you next time. Thank you.